Hi everyone. So in this video we are in JC1 H1 Mathematics and we're on the topic of applications of integration. Alright, so we have covered a few questions already in class, and in this video we will just go through some of the questions that we did not get to address in class. Okay, where I think I'll spend a little bit more time talking through what are some of these questions over here. Okay, so without further ado, let us jump right to question 8. Okay, so for question 8, so let's take a look at this question. So a company is considering a new manufacturing process on one of its plants. The new process provides substantial initial savings, with the savings declining with time x. So x over here refers to time, right? So first information over here. Now we have the rate of savings given by this function, right, over here, right? And then we have the rates of cost in thousands of dollars given by this expression over here. Okay, so these are the information that we'll be using for this equation. Now, then the company thinks that it is justifiable to use the new process as long as the rate of savings is equal to or more than the rate of cost. So this is the one that we will be translating into math. Okay, we'll be translating into math. Okay, then right, we are also looking at for how many years should the company use the new process. Okay, so the question over here is for how many years, right, should the company use the new process, right? So this is a first glance at the question. Okay, so now the thing is, right, let's go back to this sentence again. As it is justifiable to use the new process as long as rates of savings is equal to or more than the rate of cost. So this means that this rate of savings and this rate of cost, right? So this should be greater than or equal to something like that. Okay, apologies. So the rate of savings over here, right? And this rate of cost over here, right? So rate of savings must be greater or more than the rate of cost, right? Something like that. So when we want to look for something more than another thing, right? I think it's a little bit harder to visualize this over here, right? So let's do this, okay? Let's do this algebraically, right? And let's see how this works. So we have savings more than the cost over here. Okay, so savings would be 100 minus x squared, okay, greater than or equal to x squared plus 14 over 3x. Okay, so if I were to rearrange, I have 2x squared plus 14 over 3x minus 100 less than 0. Okay, so multiply by 3 and divide by 2, I will have something like 3x squared plus 7x and then minus 150. Okay, so that this would be the easiest form over here, and I can factorize this to something like this. So I will have a 3x plus 25 and I have a x minus 6. Okay, so with this over here, right, let me sketch this quadratic graph, right? So over here I have a negative 25 over 3. I have 6 over here, right? So for the portion below 0, because I want it to be below 0, so I'm going to look at this part of the graph, which in turn will give me between here, right, which will give me this region over here, right? So this tells me that my inequality would be between, right, negative 25 over 3 and 6. Now, but when we think again, right, because x is time, right, x is time, so what do we do for time is that time is always at least 0. So I'm going to restrict this inequality to the final answer where it will be between 0 and 6. So this would be the final answer over here. So then the conclusion over here is the company should use for 6 years. Okay, now there is another interpretation over here, right? There's another interpretation over here. So this over here, right here is M1 using the algebra. Now the second way of doing this, right, is that because we are looking at inequality, right, another way of solving this inequality is by looking at the graph of the function. So over here, if you were to use your GC, you will get this graph over here. All right, so like this, right? So we are looking for the part where, okay, referring to this one over here, we are looking for the part where the sales, which is our red color curve over here, is greater than the blue color curve over here. So when is the red color curve above the blue color curve? It is actually over here. So it will be taking this point as the intersection. So it will be in this region, right? Between 0 to this unknown number over here, right? So the method that we're going to do is we're going to find the intersection point first, right? We can make use of GC to find the intersection point. We can also use algebra to find the intersection point, which will be x equals to 6 lah. Okay, or x equals to negative 25 over 3, but we are going to take this one. So making use of this intersection point, okay, making use of this intersection point over here. So this means that following this inequality, following this region, right, it will be just between 0 to 6. Okay, then we can write our conclusion. So they should use this new process for 6 years. Okay, so this would be the second method in which we could use to solve, right? So once again, solving inequality doesn't have to always be algebraic. We can also make use of the graph to solve. Okay, okay, so part 2 over here. Part 2, right, what will be the net total savings during this period, right? So the net total saving during this period would mean that between these 6 years, right, in between these 6 years, what would be the savings? And actually how the savings come from? Savings, right, actually come from this this thing over here, where we will get our sales, amount of sales, minus off the cost, something like that, right? And then we're going to add up all the sales from 0 to 6. Okay, so this means that, right, because what we're adding up is not like a fixed number, we're adding up a curve over here. So technically speaking, right, it translates to us adding up all this area over here. So actually, in fact, we're adding up the area between these two curves. Okay, okay, so then, right, for the savings, right, in part B, right, so the total savings, okay, would be like this. Okay, so we're going to integrate, right, the sales minus off the cost. So it'll be SX minus off CX with respect to X, from where to where? From 0 all the way to 6. Okay, so now over here, right, 0 to 6. Okay, so what was our function for XX again? The function would be 100, sorry, let me write. Okay, 100 minus x squared, then minus of x squared plus 14 over 3x dx. Okay, something like that. Okay, so with this over here, we will have, okay, 0 to 6, 100 minus 2x squared minus 14 over 3x dx. Okay. Now, so there are two ways in which you can do this, because in the question they didn't ask us for the exact amount, right? So what we could do is we could actually use our GC to evaluate directly. Okay, and making use of our GC, right, we'll get 372. Okay, however, if you want to do it manually, right, if you want to integrate it manually also can. So it will be 100 x power 0 plus 1 become 100x. This one will be 2x power plus 1 divided by new power. This one would be x square, then divided by new power will be 7 over 3, right? So something like that, x squared. Then from 0 to 6. Okay, so subbing in, we would have 372. Okay, so let me put in this thing over here. Okay, so something like that. Okay, so the conclusion that we'll get, right, this is 372, but if you look back at the question again, the question says that all these rates, right, are in thousands of dollars. So the conclusion over here would be the company can save a total of 372,000 in the 6 months over the 6-year period. Okay, so this is how we would do part B. Okay, so questions 9 to 12 are the rather short questions, alright? And I think like this, the purpose of these questions are just for us to model and how do we form the integral on how do we calculate the area between the two curves. Okay, so in this accompanying figure over here, the function f, this function f over here, right, gives the rate of increase of an individual's pulse rate when he walked a prescribed course on the treadmill of 6 months ago. Then the function g, right, is the same thing but more recent. Okay, so means that before this, 6 months ago, the heart rate is higher. 6 months later, the heart rate is lower, something like that, or the rate of increase is lower, so it doesn't really strain him and so on. Okay, so now give an interpretation of the area of region S and find an expression for A in terms of a definite integral involving f and g. So this one over here, we have two tasks to do. We need to give an interpretation of the area A. Give the interpretation of the area of region S, and we want to find an expression for A in terms of this. Okay, so what is going on is, now what is S? Because we see that initially, so this is like before, 6 months ago. This one will be after, right? So the increase is actually lower, right? So what do we mean by this area is actually the amount of reduction. Okay, so we can say that A is the reduction of the person's heart rate. Okay, something like that. Right, a reduction in the individual's pulse rate 6 months later. So I think we'll make use of the phrasing above. Okay, now then how do we write this area? So this area, right, you can see is actually this area A, right, written as an integral is the sum of the one before minus the one after. So the curve above minus the curve below in terms of t, because the variable over here is t, from where to where? From 0 until b, like that. Okay, so mainly like that. So this is the integral, that's all. Okay, so I think it's just a process of us transcribing from the question into an integral. Okay. Now looking at the next question over there, okay, so we have a rate of change of revenue of company A over time interval 0 to t is ft dollars per week. So this is the rate of change of the revenue of the company given by ft. Okay, and then of company A, right? Then rate of change of revenue of company B, right, is given by gt over the same period of time. Okay, so find an expression, okay, in terms of definite integrals involving f and g. Now, giving the additional revenue that the company B will have over company A. So I think this is mainly an English thing. So mainly, right, is from beginning to the end, how much does B have more over A? Something like that. Okay, how much does B have more over than A? Okay, now so let us look at the graphs again. Now this one is actually for B, company B. This blue curve is actually for company A. So let's take a look at the first region over here, right? In this particular region, the graph of A is above the graph of B, which tells us that A's revenue is higher than B. That means A earns more than B, right? So over here, this part would be this part would be like B. Okay, so B will have less revenue than A. Okay, so A overtakes B. Now in the second part over here, we see that the curve of B is above the curve of A. So in this section, B has more revenue than A. So what is the difference of their revenue actually? The difference of their revenue is simply the area in between these two curves. right? So this one is the part where B earns more than 8, right? So this is going to be a positive value because B earns more than 8, okay? But at the same time over here, okay, for this region over here, A actually earns more than B, right? So actually we need to take away the amount that A earns more than B so that we can find the balance, something like that, okay? So what would the additional revenue be? Okay, the additional revenue will come in the form of, now let us settle this positive part first. For the positive part, I'm going to integrate from T1 to T of this curve, the curve for B minus the curve for A, something like that. Okay, can so this one over here is for this integral. Okay, now the second area over here, I will need to minus off this area over here. So it will be minus of the A curve minus the B curve, right? So I need to minus off from 0 to T1 of the curve above minus the curve below, minus away the extra revenue that A had for this period. Okay, and that's all for this question. It's just a exercise for us to model and write out the integral. Okay, something like that. Okay, now let's follow up with question 11. Now two cars start up side by side and travel along a straight road. So the velocity of car is ft, car number 1, sorry, I think there's a typo over here. So velocity of car number 1, okay? So over here, this curve over here, oops, okay, so this red color curve over here, right, this is actually for car number 1. And this blue color curve over here, right, the one with GT over here, this is for car number 2. Okay, then right, we see that actually so this is just the velocity. Okay, so the area of region 1, this region is A1, this region is A2, right? So write down this term in terms of A1 and A2. So what does each of these integral mean? Okay, so let us dissect directly. Now, for the first one, it will be GT minus FT. So GT should be the one above, FT should be the one below. So where is GT above AT? From T1 to T. So it's actually from time is T1 to T, this GT is above that FT, right? Something like that, right? So this first section refers to A2. Okay, so that's the first section. Okay, now the second section obviously, okay, will be A1, but let's see, from 0 to T1, FT minus GT. So FT is the one above, GT is the one below. Then because one above, one below, this is the area in between them. Okay, so this region here represents A1. So it's just A2 minus A1. Okay, now, so what does the number obtained in part A represent? Okay, so what are we looking at is, right, now over here, what do we mean by this part of the graph? Or maybe what do we mean by this part of the graph over here? This part of the graph says that car number 2 is actually ahead of car number 1 because we are looking for the distance of car 2 in front of car 1. Minus away the original part where car 1 is more than car 2. Something like that, right? So the answer should be, okay, so it's just the distance that car 2 is ahead of car 1 after t seconds. Now let's take a look at the graph again. This graph, right, is actually a velocity graph, right? So this one over here, one more time, is actually a velocity time graph over here, right? So back in EMATS, what we've learned is the area under the curve for a velocity time graph or this speed time graph is actually distance, okay? Okay, and because of that, we are actually looking at the distance traveled by car number 2 ahead of car number 1. So that's just it, okay? Okay, now hopefully this is not too confusing for you. Okay, so last question in number 12. So this is a turbocharged engine versus standard engine. So let's read the question over here. We have two identical models of the engine, right? So the former one, the standard engine, is given by this, right? So this is the standard engine, right? Then this one over here would be the turbocharged engine. Okay, turbocharged one over here. Okay, so how much faster? Okay, is the turbocharged model moving than the model with the standard engine at the end of a 10-second one? Okay, so let's go back to our EMAF concept again. Okay, so remember last time when we did the EMAF concept, right? Now from a distance time graph, if we were to take the gradient, okay, of the distance time graph, we will get speed, right? Same thing for speed. From a speed time graph, if we were to take a gradient, we will actually get our acceleration. So this concept over here is actually our differentiation concept. dy dx actually is just a d dt, differentiate with time, okay, something like that. Now in the same way, we've also learned that in a speed time graph, if we look for area under curve, right, this one over here would be the distance. So in the same way, if we have a acceleration graph, if we look for the area under curve, it will give us the speed. So what is actually the area under curve in math? Is actually integration. Okay, so what we're actually going to do in this question is we're going to integrate the acceleration, right, for a 10-second test. So we will integrate for 10 seconds of the turbocharged minus the standard one, so that we can get a difference, okay, we can get a difference in the speed, okay, something like that. So we're going to integrate acceleration to get our speed, and we are going to look at the difference to see the difference in speed. Okay, can the difference in speed would be, now let's integrate from 0 to 10 seconds, okay, 0 to, because it's a 10-second test of gt, okay, the second function, the one with the turbocharged one, minus away the standard one. Okay, so how would this look like from 0 to 10 of this entire function, 4 plus 1.2t plus 0.03t square, then minus of the first one, 4 plus 0.8t dt. Okay, so I think using your GC, okay, you can just key in using your GC, this would give you a value of 30. Okay, something like that. So this means that the turbocharged model will be moving 30, okay, what units is this? 30 feet per second faster, okay, than the standard model. Okay, something like that. All right, so here ends the tutorial for applications of integration, namely to find area under the graph. Okay, so I think I think it's just a matter of getting used to what is the meaning behind the integration, which is to find the area under the graph, and what does the area under the graph mean within all these contexts. Okay, so that's all for this video, and all the best. Okay, see you in the next one.